we are asked to find the domain and range of the exponential function f of x is equal to negative 2 to the x plus 1 power plus 3. The easiest way to find the domain and range of a function is to think about its graph. Remember, domain is found by taking the x-coordinate of the leftmost point to the x-coordinate of the rightmost point, and the range would be the y-coordinate of the lowest point to the y-coordinate of the highest point. Now, if your graph has arrows such as these, that means some of these values will actually be infinity or negative infinity. What I have on the board here is the basic function g of x equal 2 to the x. This is our basic exponential function with no translations. In order to find the domain and range of our function, we're going to have to translate this basic function by shifting it left 1, because remember, inside the exponent is always a backwards shift. We're going to translate the graph up 3 units, and we also have to reflect the graph about the x-axis, which is a fancy way of saying we're going to flip it upside down. So, first of all, our left-right shift. There's not too much to show in terms of a left-right shift, but basically that would make the graph look sort of like this. That would shift it to the right 1 unit. But then we also have to shift the graph up 3 units. Now remember, your basic exponential function has a horizontal asymptote at y equals 0, which is the x-axis. If we shift the graph up 3 units, that means we will now have a new horizontal asymptote, which I will put here, at y equal 3. Now remember, our exponential function gets infinitely close to that asymptote, but it never actually reaches it. So our graph would look like something like this if I were to shift left 1 and up 3 units. But we do have one other important factor here, and that is the negative sign in front of the 2. That means we have to take our graph and reflect it over that asymptote. So if I do that, our new graph looks something like this. Now that I've graphed f of x is equal to negative 2 to the x plus 1 plus 3, we can now find the domain and range. The domain would be the x-coordinate of the leftmost point, which in this case, because the arrow, the graph goes off to negative infinity in the x direction, to the x-coordinate of the y-most point, which again, I have another arrow. The graph is going down faster than it goes to the right, much, much faster, but it does continue to go to the right forever. It does not stop, and therefore, my domain goes to positive infinity. As a matter of fact, every exponential function will have a domain of negative infinity to positive infinity, no matter what the shifts or translations. The one thing that does change from function to function will be our range. Now remember, I said the range is our y-coordinate of the bottom to the y-coordinate of the top. Well, again, I don't really have a bottom point per se. My graph goes down. The arrow indicates that I'm going down forever, so my y's go down to negative infinity. I also don't really have a highest point. My points are going to be getting closer and closer and closer to this horizontal asymptote, but it'll never actually reach 3. So in interval notation, the way we indicate that, we're going to say that the range goes up to 3, but does not quite reach 3, and we're going to use a parentheses in our interval notation to indicate that 3 is not actually included in our range. We're just getting infinitely close to 3. So the domain of this function is negative infinity to positive infinity, and the range is negative infinity to 3. I will sort of give you a shortcut formula for this type of problem. If you are looking at f of x equals a times b to the x minus h plus k. This would be the standard form for our exponential equation, where a would be our stretching factor and or flipping factor, and h and k would be our two shifts. Again, the domain is going to be negative infinity to positive infinity all the time. That's easy. The range will depend on the a. If your a is a positive number, greater than 0, then the range will be from k to infinity, because at that point your graph would be up and above the asymptote. Notice again, I am using a parenthesis on the k because this value is not included as part of our range. However, in our example, we had an a that was less than 0, which means our range was negative infinity to k, again with a parenthesis on the k. That would be how we could find the domain and range of any exponential function, even without actually taking the time to graph it.